Hi students, welcome to Sunil's tutorial. I'm Sunil Nurwani and today we'll be doing this chapter called as logic. Let's see another sum. Take down the sum please. Consider the following statements. Consider the following statements. Consider the following statements. If price increases, then demand falls. If price increases, then demand falls. If price increases, then demand falls. Second statement. If price does not increase, then demand does not fall. If price does not increase, then demand does not fall. Third, if demand falls, then price increases. If demand falls, then price increases. Next, if demand does not fall, then price does not increase. If demand does not fall, then price does not increase. If demand does not fall, then price does not increase. Identify the statements having the same meaning. Identify the statements having same meaning. Now let us assume that P is equal to price increases. Q is equal to demand falls. Now let's see the statements. They are saying that if price increases, then demand falls. So symbolically this is going to be written with an implication. If price increases, then demand falls. Next, if price does not increase, if price does not increase, then demand does not fall. Next.
So, sir, is it okay to put the not sign after the...
No, you have to put it always before. The not always comes before. If demand falls, then price increases. And if demand does not fall, then price does not increase. So these are your four statements. You have to find which of them are logically equivalent. Let's see truth table. P, Q. Right? You want P implication Q. First, for the first one. You want not P. You want not Q. Not P implication not Q. Then you need Q implication P. Then you need not Q implication not P. Right? Let's see this. T, T, F, F. T, F, T, F. P implication Q. For implication, if the first statement is true, the second statement is false, then the answer is false. The first is true, the second is false, therefore the answer is false, otherwise the answer is always true. For not statement, T becomes F, F becomes T. So T becomes F, F becomes T. For not statement, T becomes F, F becomes T. You are doing a not statement of Q. So T becomes F, F becomes T. T becomes F, F becomes T. I want an implication between these two. Implication, the rule is if the first statement is true and the second statement is false, then the answer is false. False, false is false, false. First statement is true, second statement is false, therefore the answer is false. Sorry, these two will be true. And this is going to be true. If the first statement is true and the second statement is false, only then is the answer false. Now I need an implication between Q and P. T implication T. Remember, you have to read reverse order. First statement is this. So true, false is true. False, true is true. True, false is false. If the first statement is true, the second statement is false, then the answer is false. False, false is true. Now I need implication between these two. Reverse order. false false is true, true false is false, false true is true, true true is true. Now let us look at column 1, 2, 3 and 4. Now if you look at column 1, 2, 3, 4, you will see that column 1 and column 4 have the same truth value T, F, T, T, and column 2 and column 3 have the same truth value T, T, F, T, right? You will say as column 1 and 4 have same truth value, therefore I can say that column 1 and column 4 have same truth value, therefore I can say that P implication Q is logically equivalent to not Q implication not P. Sorry. Also, column 2 and column 3 have same truth value, therefore not P implication not Q is logically equivalent to Q implication P, right? Hence I can say that statements 1 and 4 have same meaning, and statements 2 and 3 have same meaning. That's how you find out meaning of a statement using logic.
Sir, could you repeat that method to remember that formula?
For all of them?
Yeah, for implication and what?
And is TTT. If the first statement is true, second statement is true, then the answer is true. Or is FFF. If the first statement is false, second statement is false, then the answer is false. Not is reverse. True becomes false and false becomes true. Implication. That is if then statement. Implication is first statement is true, second statement is false, then the answer is false. And biconditional. Biconditional is if both are same, if both the conditions are same, if both are true or both are false, then the answer is true. Right?
So not cutting repeat?
If true becomes false, false becomes true.
Achha.
Right? Okay. Next, take on next question, please. Everyone finish copying this? Rewrite the following statements. Rewrite the following statements. Rewrite the following statements without using if-then. Rewrite the following statements without using if-then. Rewrite the following statements without using if-then. First statement: if it rains, then the principal declares a holiday. If it rains, the principal declares a holiday. Right? Now guys, let us assume, let P be equal to it rains. And let us assume that Q is the principal declares a holiday. Right? They've given you if it rains, then the principal declares a holiday. Right? Symbolically, this is what they've given you. Now, how do I convert this? This can be written as, guys, the answer for this will be if it rains and the principal declares a holiday, the answer will be it does not rain or the principal declares a holiday. This is going to be not P or Q. When you want to write this without using if then you have to make the first statement not and the second statement connector will be or. So write the answer please. If it rains, the principal declares a holiday. It does not rain or the principal declares a holiday. It does not rain or the principal declares a holiday. It does not rain or the principal declares a holiday. It does not rain or the principal declares a holiday. Take on another statement please. If the quadrilateral is a rhombus, if the quadrilateral is a rhombus, then it is not a square. If the quadrilateral is a rhombus, then it is not a square. If the quadrilateral is a rhombus, then it is not a square. Right, what will be the statement without if then here?
So P is a quadrilateral and Q is, it is not a square.
So in that case, the answer will be it is not a quadrilateral. Right, it is not a answer will be it is not a quadrilateral or it is not a square. Right, see, they've given you that
The implication of
if it is a quadrilateral, then it is, what is that?
So it's,
The question says that if it is a quadrilateral, no.
if the quadrilateral is a rhombus, then it is not a square.
If the quadrilateral is a rhombus, then it is not a square. Right, P is the quadrilateral is a rhombus. Q is, it is not a square. They give you P implication Q. The answer for that is not P or Q. Right? So in that case it will be the quadrilateral is not a rhombus or it is not a square. Right? The quadrilateral is not a rhombus or it is not a square. The quadrilateral is not a rhombus or it is not a square. Next guys, please take down some rules of negation. Not of P or Q is not P and not Q. Not of P and Q is not P or not Q. Not of P is P. Not of P implication Q is P and not Q. And not of P biconditional Q is P and not Q or not P and Q. These are called as your rules of negation. This is how you make negation of a connector. Right? Let's see sums based on this. Question. Find the negation of. Find the negation of. First one. P and not Q. guys, let's see this answer. I want to find negation of P and not Q. Right? Now for AND, when I open the bracket, not gets multiplied with P. Not of AND, guys, as per the rule, not of AND is nothing but OR. Not of Q is nothing but Q. Not is the given function as per the rules. I will the answer. Sum is over. Open the bracket. Not multiplied with P will be not P. Not of AND is OR. Not of Q is Q. Right? See, I'll show you another sum. Suppose if they tell you find not of, no. The sum is P implication Q and R. P implication Q and R. I want to find not of P implication Q and R. Now guys, look at the rule. This is my first condition, this is my second condition. When I am making not, guys, see the rule. When I am making not, I provide the first condition as it is and not second condition. First condition and not second condition. First condition and not second condition. Now again look at the rule. Not of Q and R. Guys, see the second rule. Not of Q and R. Not for both the conditions is not of first or not of second. So this is going to be not of first or not of second. Finish. That's the answer. Next, let's see another sum of this kind. P and Q implication R. Right? I want negation of this. That means I want not of P and Q implication R. Right? Now the rule says, guys, see the rule. First condition, second condition. I want not of this. So it is not of first condition or not of second condition. So this is going to be not of first condition or not of second condition. This is not P or. Now for Q implication R, apply the rule straightforward. First condition and not second condition. I have a not outside Q implication R. Not of two conditions is first condition and not second condition. So this is going to be first condition and not second condition. So the answer will be not P or Q and not R. Right? Let's see another sum of this kind. P or Q and R. P or Q and R. I want not of P or Q and R. Right? Or function. Whenever you have negation of OR, it is negation of first condition and negation of second condition. So it is negation of first condition and negation of second condition. Negation of first condition and negation of second condition. Negation of P and open the bracket. Now when you have AND function, not of AND function is negation of first condition or negation of the second condition. Next, P implication Q and Q implication R. I want the negation of this. Negation of P implication Q and Q implication R. Whenever you have AND function, it will be negation of the first condition or negation of the second condition. For implication, it is first condition and not second condition. First condition and not second condition, or first condition and not second condition. So the answer will be this: P and not Q, or Q and not R. Right? Next, take the next type of term. Write the negation of the following. Write the negation of the following. Write the negation of the following. Now we will do this in sentence form. We have done this symbolically, now we will do it in sentence form. Write the negation of the following. First one, I go to the college. I go to college, or I go for a movie. I go to college, or I go for a movie.
One sentence.
I go to college, or I go for a movie. Right? Let's assume that P is I go to college. Q is I go for a movie. They've given me P or Q. They've asked me to make negation of this. So what will be the negation of P or Q? Negation of P or Q will be not P and not Q. So statement wise, I do not go to the college. I do not go to the college, and I do not go to the movie. I do not go for a movie. So write the answer. The answer for this will be I do not go to college. I do not go to college, and I do not go for a movie. I do not go to a college, and I do not go for a movie. Second, A is tall and B is fair. A is tall and B is fair. P is A is tall. Q is B is fair. Right? A is tall and B is fair. Let's see the negation of this. Negation will be not of P and Q. That's not P or not Q. So the answer for that will be A is not tall,
B is not
or
B.
B is not fair. A is not tall, or B is not fair. A is not tall, or B is not fair. Next, if n is a prime number, then n is an odd number.
So if n is a prime number, then n is an odd number.
If n is a prime number, then it is an odd number. P is n is a prime number. Q is n is an odd number. The statement given to you is if n is a prime number, then n is an odd number. The negation for this is not of P implication Q. For implication, it is first condition and not second condition.
If n is a prime number,
Right. N is a prime number and n is not an odd number. Right? The answer for that will be n is a prime number and n is not an odd number. N is a prime number and n is not an odd number. A plus b the whole square is equal to a square plus b square if and only if AB is equal to 0. P is a plus b the whole square is equal to a square plus b square. Q is AB is equal to 0. Statement given to you is P biconditional Q. I want the negation of this. Negation is not of P biconditional Q. Not will be P and not Q, or not P and Q. That's the negation of biconditional. Right? The answer for that will be answer a plus b the whole square is equal to a square plus b square, and AB is not equal to 0, or a plus b the whole square is not equal to a square plus b square, and AB is equal to 0. That will be the negation of it. Next, how do you find out dual? Now, dual of AND is OR, and dual of OR is AND. So all you have to do is convert AND to OR and OR to AND. For example, if I give you a question, give the dual of P and P is logically equivalent to P. So what will be the dual of this? All you have to do is convert AND to OR to AND. So P or P is logically equivalent to P. Finish, sum is over. That's how you make the dual. Right? Let's see another sum of this kind. P or Q is logically equivalent to Q or P. So what will be the dual of this? All gets converted to AND. So P and Q is logically equivalent to Q and P. P and Q and R is logically equivalent to P and Q and R. The answer for this is going to be P or Q or R is logically equivalent to P or Q or R. Done. This finishes this chapter. We'll stop this here for the day. Thank you very much.